The universe, vast and mysterious, has always inspired wonder about what lies beyond its furthest reaches. To even begin exploring this question, it is important to understand how scientists define the edge of the universe and what it means for something to exist beyond it. The observable universe is the region of space we can see, limited by the speed of light and the age of the universe itself. Light takes time to travel, and since the universe is about 13.8 billion years old, we can only observe objects whose light has had enough time to reach us since the Big Bang. This defines a spherical volume centered on Earth with a radius of about 46.5 billion light-years, accounting for the expansion of space itself over time. But this is not the edge of all that exists. Rather, it is the edge of what is observable to us. Beyond this observable boundary, the universe could continue, perhaps infinitely. The edge is not a physical wall, border, or barrier. Instead, it is simply the limit of our current view, a horizon beyond which light hasn't had time to reach us. If you could magically jump to a galaxy at the edge of our observable universe, you would find yourself in a region of space that looks much like our own, with galaxies stretching out in every direction, and a new, different observable horizon surrounding you. So, what exists beyond our observable universe? According to the most widely accepted models of cosmology, the universe is either infinite or so vast that it is effectively endless for all practical purposes. The regions beyond what we can observe are thought to be fundamentally similar to the part we can see. They contain galaxies, stars, gas, dark matter, and perhaps even life governed by the same physical laws. However, the possibility remains that the universe is finite but unbounded, much like the surface of a sphere. Imagine standing on the surface of a planet. You can walk forever without encountering a physical edge, but the area you traverse is still finite. Some cosmological models suggest that space might be curved or connected in such a way that traveling far enough in one direction could, in theory, bring you back to your starting point. Although on cosmic scales, this is beyond our current ability to test. Another intriguing possibility is that our universe is just one part of a much larger multiverse. This concept suggests that what we perceive as the universe is just a single bubble among potentially countless others, each with its own distinct properties, physical constants, or even dimensions. The edges of our universe, in this scenario, might be like the boundaries of a bubble in a vast foam of universes, with other bubbles beyond our own that are forever inaccessible to us. But what about the very fabric of space itself? Does it continue infinitely, or does it have a boundary? Here, things get even more speculative. According to Einstein's theory of general relativity, space and time are intertwined, forming a four-dimensional fabric known as space-time. This fabric can be curved, stretched, or compressed, but it doesn't have a conventional edge or ending. If our universe is infinite, it never ends. There is no beyond, just more universe. If it is finite and unbounded, then again, there is no edge, just a continuous looping space. Some theories of the early universe suggest that space itself grew out of a tiny, hot, dense state, the Big Bang. In this view, the universe doesn't expand into pre-existing space. Rather, space itself is expanding everywhere at once. There is no outside for the universe to expand into. The universe is all there is. Beyond its edge, in a physical sense, there is nothing. No space, no time, no matter. Quantum physics introduces even more exotic possibilities. Some interpretations suggest that, at the smallest scales, space and time themselves might be quantized or discrete, with a fundamental limit beyond which the concepts of space and time no longer apply. In such a scenario, asking what lies beyond the universe is like asking what is north of the North Pole. A question that loses its meaning because the concepts themselves don't exist beyond a certain point. From a philosophical perspective, the question touches on the limits of human understanding. Our brains are wired to think in terms of boundaries, edges, and things outside of other things. Yet, the universe, by definition, encompasses all of space and time. If there is a beyond, it might be something entirely outside the realm of our experience and comprehension, governed by principles we cannot yet imagine. It's also important to recognize the role of observational evidence in science. We can only make statements about what lies beyond the observable universe by extending the laws of physics as we know them and by relying on mathematical models and indirect evidence. If there are fundamental changes in the laws of physics beyond what we can observe, we may never be able to detect them or know for sure what lies out there. Despite these profound uncertainties, exploring the edges of the universe has practical consequences for science. Understanding the shape and extent of the universe affects our models of its fate. If the universe is infinite, it could expand forever, gradually cooling and fading into darkness. If it is finite and closed, it could eventually stop expanding and collapse in a big crunch. Ongoing observations of distant supernovae and the cosmic microwave background help scientists refine these models. But the ultimate truth about what lies beyond the edge remains elusive. In the end, the question of what is beyond the edge of the universe is as much about the boundaries of human curiosity as it is about the cosmos itself. We may never find a definitive answer, but in seeking it, we expand our understanding of reality and our place within it. The universe, with its vastness and mystery, continues to inspire us to look outward, to ask questions, and to imagine what might lie just beyond the horizon of our knowledge.